or insight that, these look like fairly simple, straightforward kinds of policies, but if you think deeply enough about them, to actually enforce them in practice requires you to have the full machinery of the usage control model. Okay? So it requires the full power of Yukon. And then the implementation models have to get into the detailed protocols for doing all this. We obviously don't have time to cover this at all. And just close with these concluding remarks that trusted computing can work for some aspects of information sharing. We have shown a fairly simple kind of information sharing here. How far we can push it, that remains a question for further investigation. And then thinking about security problems using this sort of three-layer framework is a possible useful thing that could be done to problems other than information sharing and to security platforms other than trusted computing. And Yukon also is a useful way of... we need something with that kind of power to realistically model these problems. And that's... I don't know if we have some time for question and answer or kind of taken it down to the limit here, but...
we have time for a couple.
Okay. They may not go online. Okay. Yes.
So my question is the basis of this seems to be that the TPM module really is secure and keeps the keys hidden and things like that. If that gets broken, does that kind of destroy the whole system?
Yeah. So so that does destroy the whole system. And there are a couple of ways of answering that concern. One is which you'll see sort of mentioned in the TPM community a lot, that, okay, we are really trying to protect against software-only attacks. We are not trying to protect against hardware attacks and hardware tampering. And if you're doing tampering at the hardware level, there's information in the clear on various system buses and so on. So unless you're going to start encrypting information that's on the system buses on your motherboard, somebody can just stick a probe in there and pick up some of that information. And is it really realistic for us to start encrypting that stuff? I mean, so they don't want to even think about that level of detail. So you may not need to interfere with the TPM. You may be able to do things by just probes on the motherboard. But the average Joe is not going to do that. That's so that. I said I'll give you two. I've kind of forgotten the second one that I wanted to mention. So.
I'm sorry, I could not do some of the text in your slides, and now you cannot hear.
You cannot.
Could you please elaborate on policy change?
Policy change? Well, I talked about policy flexibility. So really, in any given Yukon specification, you either have to kind of, look, at the end of the day, this is a language. Okay, so here we have specified a very specific policy. Now, you could put some kind of a case statement and say, if policy is this, here are the checks you need to make. Or if policy is this, here are the checks you need to make. But then you open up the question of where do I get this, how do I determine which policy is in force? So Yukon per se was not really designed to be, it was designed to make these kinds of statements for a particular specific policy rather than making the policy a parameter in the enforcement. So, I don't know if I'm directly answering your question, but that's the...
I think you are, but
yeah.
in the next slide, you have those layers. Right? Let's say we do the test and then go after. Is there another arrow which comes here? Either another arrow from the last layer goes back to the first layer.
Yeah, so, look, my intention is not to present this as a top-down waterfall style software engineering kind of thing. This is not at all intended to convey that picture. This is more, my analogy is always to network protocols. So, you have stuff happening at all layers all the time. So you probably need to be working at all these layers all the time. The activity and thinking is concurrent. What this should be able to help you do is to sort of move the questions up and down to the correct layers. So if you're confronting something in the implementation model and you get stuck and you need to fix some policy because your developers have already gone down a particular path and implemented something and it's too late and too expensive to fix it, yeah, but you should still bump that up to the policy model layer and reconcile it there. And then, so I have no expectation that you'll be able to actually address any of this in a thinking in only one layer at a time, or thinking in a sort of top-down way or a bottom-up way. At the same time, you want to make what you do at each of these layers relatively robust, so that if your policy models change, if your policy requirements change at the policy model layer, you can do some small tweaks at the enforcement layer and it'll be taken care of. And you can do some small tweaks at the implementation layer and it'll get taken care of, because you can identify the points where policy is being enforced. So that's the hope. It's a modest hope.
Oh, there we go. So I'll just make two observations for you. The first is that part of this really needs to be at the implementation level, and maybe enforcement as well, is a threat model, and that goes to the TPM question. The threat model for the standard TPM implementation is the average business user with academic lab, business lab kind of capabilities, rather than a governmental entity. And if you're going to go up against that, you use epoxy with lead, and you use other kinds of controls on the chip to protect the buses, or on the motherboard to protect the buses. So there is that other element, is understanding the threat model. And the second observation is one of the nice things that occurs to me as you were talking about Yukon is that looks like that would be a good model to include data provenance as another aspect of elements with the data, in addition to the control. Any comment to that?
Yeah, so my hope is that we would be able to capture those kinds of things as attributes. Attributes can be security levels, clearances, access control lists, various timestamps, various usage counts. So my expectation or my belief is that I should be able to capture that in a suitable attribute and track it.
But then it needs to be protected.
Yeah, so the point is that the attributes in the usage control model are updatable in two ways. One is by direct administrative access. So somebody has the authority to go and, in this example, if I enroll somebody into a group, then I'm changing their membership attribute to true. Okay, so that's a direct it's sort of an update of an attribute that I'm doing. So that's one way of doing it. Another way of thinking about it is that I did some operation on that object, and as a side effect, things got updated. So I think the latter way of thinking about it actually covers the former, and it also implies some control of authorization over who can do that. But yes, we do need some administrative model aspect to it. So in this particular exercise, we have kind of commingled the administrative model, and I said we have operations to add and to enroll and disenroll a member, add and remove a document, and then we have the crucial operation of a member reading a document, right? So in one sense, that's the real operation that we are concerned about. The other two are administrative operations. And we've